Hey guys, welcome to our last video for target 1B, where we're switching between rational and radical form. The last thing we're going to look at is comparing the two, comparing rational exponents to radical exponents. And we really do that by just switching them and seeing if they're equal. So, following these directions, we want to fill in these boxes with the correct symbol, either equals or not equals. And we always have to show work to explain our choice. If we look at example 1, the right says 7d to the 2/5. The left says the 5th root of 7d. So, are these equal? For these, we're always going to switch the one that's in radical form into rational form. It's a little easier to see if they're equal that way. So looking at just the right side, because the left side is already in a rational exponent form, right? So I don't have to change that one. That one just stays the same. On the left side, on the right side, I have to first decide what my base is. My base is 7d. So remember, your base is what goes under, your base is what's being raised to the power. Since both the 7 and the d are underneath that square or underneath that radical, they both have to go in parentheses. Then my exponent, which becomes my numerator, is just 1, right? Because there isn't any there. So that's 1 there. And my root is 5. So that becomes my denominator. So now I can see I have 7d to the 2/5 and 7d to the 1/5, right? Since this has a 2 and that has a 1, those things are not equal. All right, looking at example 2. Now, both of these, right, have a radical in them. So I have to switch both of them. If I look at the left side, I have the 4th root of 81x squared. The right side, I have 3 square root x. So, looking at the left side, 81x squared is all under the square root. So that's my base that gets put in parentheses. My exponent is simply 1. Right? So that becomes my numerator. And my root is 4. So that becomes my denominator. On the right side, just x is under my radical. So just x is being raised to the power. That means this 3 is a coefficient out in front. Then my exponent on this is just 1, because there's nothing there, right? My roots, right, again, there's nothing there. A root with nothing there is 2. So that becomes my denominator. Now, the right side is simplified. I can't do anything else with that. The left side, I still have parentheses, and I'm raising all of that to the 1/4. So now, again, we have to go back to target 1A. This is the power rule. I have to distribute that 1/4 to both of those, right? So I have 81 and x squared, and both of those get raised to the 1/4. 3x to the 1/2, since it just stays the same, I'm just going to write it underneath to keep my work nice and organized. So then, since this one's since 81 to the 1/4 is an actual number, right, I'm just typing that into my calculator. 81 to the 1/4 is 3. X squared to the 1/4, well, x is my base, and 2 times 1/4, right, is 1/2. So I have 3x to the 1/2. Now I can see that these things are equal. An equal sign should go in there. Okay. So those two are equal. Let's look at example 3. I have 5g to the 3/2 and the square root of 5g to the 3rd. The left side is already done. It's already in exponential form. The right side, however, is not. Okay? So I'm first going to pick out what my base is. My base is 5g. That's what's under my radical. Both of those are under the radical, so I have to use parentheses. Then, my exponent is 3. So that becomes my numerator. Then I don't have a root here. So if it's not there, it's just 2. So that becomes my denominator. And I'm just going to bring this side down. Right? So then you should see I have 5g to the 3 halves equals 5g to the 3 halves. Those are both exactly the same. So that one would be equal. Looking at example 4. Example 4 is like example 2, where now both the left and the right, have radicals in them. This is the cube root of 27x and 9 square root x. So let's start with the left side by deciding what our base is. Our base is what's under the radical. It's 27x. Right? So I have 27x. My exponent, which becomes my numerator, is just 1 because there's nothing there. My root, which becomes the denominator, is 3. Remember though, this base, right, since both 27 and x are under that radical, they have to be in parentheses. Looking on the right side now, the 9 is not under the root, so I just can write 9. I don't have to worry about it. X is what my base is. So I have x. My exponent, right, since there isn't one, is just 1, so that becomes my numerator. And then my root, since there isn't one, is 2. So that becomes my denominator. Alright, looking back at the left. Now I have the power rule. Now 27 is just that coefficient that gets raised to that power. 27 to the 1/3. X is my base that also gets raised to that power. Right? Both of those things have to be raised to the power. On the right side, 9x to the 1/2, there's no multiplication there, and there's no powers there. Right? I'm not raising that whole thing to a power or anything, so it can just stay the same. Then the last thing I have to do here is I have to find what 27 to the 1/3 is, since that's a real number. 27 to the 1/3, you should get 3 x to the 1/3, and I have 9 x to the 1/2. So now we can see these things are not equal. Alright, looking at example 5, I have 6y to the 1/3 and the cube root of 6y. The left side is already a rational exponent. I don't have to change it. I'm just going to bring it down. 6y to the 1/3. The right side, however, is a radical, so I do have to change it. So I have 6y as my base. My exponent is 1. And my root is 3. And again, 6y is my whole base, so that has to be in parentheses. The left side, still have nothing to change, just 6y 1/3, just chilling over there. The right side, now I have to raise that 6 to the 1/3. And I have to raise that y to the 1/3. I have to distribute that 1/3 to both of those. So 6y to the 1/3 on the left side. And then 6 to the 1/3. Right? If you put that in your calculator, you get some crazy decimal. It's like 1.8 approximately. And then I have y to the 1/3. Okay. And now I can see these things are not the same. This is 6y to the 1/3, and this is 1.8y to the 1/3. So these are not equal. All right, last but not least, number 6. Again, this is one where both of them are radicals, so I have to change both of them. For the left side, I have 64x squared as my base. That whole thing is being raised to my exponent, which in this case is 1. And my root, so my denominator is 6. On the right side, this 2 is just a coefficient. It gets to go out in front. Then my base x is being raised to the power of 1, because there's nothing there. And my root is 3. Right, so 2x to the 1/3. Now I just need to simplify, right? On the left, 64 is acting as just a coefficient. So it's 64 to the 1/6. X is my base. So I have x. And then 2 and 1/6 are those two exponents. And since it's being raised to a power, we're multiplying them. Then on the right side, right, 2x to the 1/3 can't be simplified anymore. So it's just going to hang out. All right. Now, 64 to the 1/6, if I put that in a calculator, you get 2. I have my base of x. And 2 times 1/6 is 1/3. Okay, so I have 2x to the 1/3. On the right side, I have 2x to the 1/3. So those are equal. That is it for our video today. Sorry, I know that one was a little bit longer than usual, but I really wanted to walk through a bunch of those problems. All right, go ahead and look at try these problems on your own problems, and we'll go over them in class tomorrow. Have a wonderful evening.